Good morning. I am Pilot Industria, and yeah, welcome to my stream this morning, or evening, or day, or whatever the time is where you are. So today I am gonna be starting a new project. As I've said in my debut, I really enjoy mechanical keyboards as a hobby, and I've designed a few of my own, but I thought I would do my next one on stream just to sort of share the process. At some point, I would really like to make a proper educational video people could actually learn how to do it from properly, but that'll have to wait for another day. I mean, I'll try and explain things as I'm going, but at the minute, I really just make up too much of this stuff as I go along, and yeah, it's just a bit of a hot mess. So I'll probably do a pre-recorded series on learning how to do this the right way, or as right as I can do it anyway, which is not very. So yeah, I guess we'll hop straight into it. So I'll just give a quick overview first. Let's hop over here. Oh, whoops, that looked a bit janky, but whatever. Yeah, so this isn't one of this is one of the keyboards I've designed. Just a render. But yeah, basically, so this is a mechanical keyboard. It is a keyboard, as you can see. But basically, you have the case, and I'll go through the parts. So if you take off all your keycaps, then you have you can see all the switches, and underneath the switches is the plate. And then, so that's God, how did I do this? Okay, yeah. So switches are out and PCB is out. So that's your case and plate, which I will be making both of those. And also the PCB, which is what everything, basically the brains of the keyboard. So some people, when they do completely custom builds, do hand-wired. So in that case, you just need like a little off-the-shelf PCB, like a TNC, I think, is a popular option. And then you have to solder that's got all of the brains on it already, and you just have to solder the switches, the key switches, to the little board. And again, some people make PCBs that interface with a TNC or whatever as a daughter board, but we are not going to be doing that today. We are going to be designing this completely from scratch. So I will be designing the PCB, populating it with all the components which I'm buying. Actually, I think I've got most of them left over from previous builds, thankfully. And then, yeah, you basically have to flash all the firmware to it, which I am going to be using QMK, purely because it's the only thing that I've used, and whilst it's a complete nightmare to work with, at least for me, at least it works. So yeah, I'll be using QMK, and basically, yeah, that's what I'm going to be doing first. I'll be designing the PCB first, and then we'll be moving on to the case and plate, and then once I get it all together, all in, I'll be soldering all the components onto the PCB and putting it all together so that it's a working keyboard. So what else have we got? Oh yeah, keycaps and your switches and the stabilizers, which on this are, well, I'll be talking through everything that's going into this keyboard as I go. But yeah, that's the gist of it. So let's which should end up with something like that. Yeah. Okay, so what are we going to be doing? Well, I guess first I don't even have a picture of it up. Let me just grab a picture of this for you. I am so prepared today, as you can see. There we go. So this is the layout I am going to be creating, so to speak. The layout I've chosen for my design. It's a weird one, as you can see. But basically it just suits my particular typing style and requirements. So I wanted something sort of like a 10 keyless in that it's got all the regular keys, but I don't really use the nav cluster much. So I've ditched the nav cluster. I'm keeping the function row because I use that. I don't use many of the the right shift and control, etc. So I'm ditching those. For some reason, every keyboard I've ever designed has ended up with a delete key directly next to between the up and right arrow keys, so I'm keeping that. ISO, is it ISO or ISO? Either way, I'll go with ISO. An ISO enter because I am British and ISO enters are love and life. And I am also putting a macro block on the left side because you can never have... Well, actually, it's mainly because starting streaming, to be honest. So because I will need loads of hotkeys for various functions, at the minute I've just got them all mapped to... Well, they're not even working very well. I'm trying to have like control numpad 1 to 3 for functions, and it's just a bit of a mess. So I think having a proper macro block which I can allocate to various streaming functions would be fantastic. And up at the top left there, one of the things that I like in QMK is dynamic macros. So it has a function where you can just hit the record button and it'll just log up to, I think it's like 120 odd key presses. And then all you have to do is hit the play button and it will play them back in sequence, which is actually really useful because it doesn't just record like characters, like it records actual things that you could... I found it really useful from a working point of view, because just something that I found really handy in the past. So that is about it for the weirdness. And something I've not tried before. In the top right, we have a rotary encoder, which I've never built a keyboard with one before. I don't know what I'm going to use it for, but I thought, why not, eh? Why not? So that's it for the layout, which is what I'm going to be making. And then what else do I need to go over before we start? I guess I'll talk about the other bits that I've bought. So the keycaps are actually sort of that colour, in that they are Canon keys Type 6, which is based on an old Sun Microsystems keyboard. But they look really cool. I really like them, despite them being fairly subdued, I guess. They're pretty tame in the grand scheme of keyboard keycaps, because you can get all sorts of bonkers combinations these days. But yeah, I just was really taken with them when I saw them, and they were a good price, and I thought, well, you can't go too far wrong. The stabilizers I am going to be using are Texi stabilizers, I think. I bought 2 sets of those because I got some clear ones, and then I got these keycaps and decided I'd get a purple set as well. the switches. I am still not 100% on switches because I have I've actually got 3 different sets of switches, and I might pick up a 4th. So I bought KTT matches. I'd just been collecting switches, to be honest. So I've got KTT matches, which are a really, really nice budget switch. And then, because I thought it would match the board better, I bought some Acco CS Lavender, which seem... They're a tactile switch as well. So switches come in 3 main flavors, to put it that way. You've got your linear switches, where it just feels the same the entire key press from top to bottom. Tactile, which has a sort of a bump you can feel when you press the key switch, which feels more, I guess, your regular old rubber dome keyboards feel most like a tactile switch. And then we've got clicky switches, which, as the name suggests, are clicky. So they've got the tactile event and a click. So, I mean, I've got a switch tester here, so not that it really means a lot at the minute, but yeah, you've... So, the KTT matches seem great, but they're pretty luminous, and I don't think they would really vibe with this board, from what I've got in mind for the case. The CS Lavenders, a really good colour match, but my god, they are the loudest switch I have. They're just so loud. The loudest switch I've encountered, I think, for a non-clicky switch. Oh, they're just horrific. Hang on a sec. I wonder if I can... I'll just quickly turn off noise suppression and... let's see if you can hear this. So... I've got my switch tester here, and... Okay, it looks like it's picking it up. So I think that is a Kaiwa box heavy burnt orange, which is what is in my current keyboard. And then this is the KTT matcher. And then this is the Acco CS Lavender. It is just so loud. And the bottom out's pretty harsh as well, but I think I could live with that. But it's just the noise. I mean, they're probably almost as... What else have I got in here that's remotely that bad? Novelty's blueberries are pretty loud. But then, I mean, clicky switches obviously win out. And then, anyway, so the CS Lavenders, they look great. They sound very loud, which is probably suboptimal for streaming. And then my third and fourth options are, well, option 3 is one that I'm missing a few of. I have a bunch of cerulean switches, which are really nice, and they're not very loud. But the problem I've got at the minute is that I don't have enough. But the supplier that I normally get them from used to only do them in sets of 70, 90, 110. But it looks like they might be starting to sell switches in boxes in sets of 10. And in that case, I should be able to just get a few to finish off, to do this project. The probably wouldn't look quite as nice as the Lavenders or option 4, but certainly they feel great and they sound great, and they would be a really good option. Which takes me to the fourth switch which I have, which came in just last week, which are purple potato switches. So I got these in a group buy. Well, I went in on the group buy in August, and they only came in last week. And they are, I think, a really good middle ground. They're a bit heavier maybe than a little bit heavier than the lavenders and the matches, but not by much, and they do feel nice, and they're not as loud as the lavenders, so I think they could be a good option. I mean, I should have parts left over, so in theory, if I don't like them, I could always swap them for some, desolder the whole board and put a different one in, but we'll see. They're also pretty loud, to be honest. At least the ceruleans are on the quieter side. Oh, apologies. I need coffee this morning. Only other thing I note, the switches in the top left for record and play are going to be making those myself. So I have, in fact, I might be able to actually share that right now. So I have been messing around with my 3D printer. Well, one of my 3D printers, which I haven't really used it a huge amount until the last couple of months, but I started making, I have a resin 3D printer, an Elegoo Mars 2, which is pretty nice. It's just, I've spent years doing regular FDM 3D printing with filament on spools, where it melts the filament and then makes one layer at a time. So moving from that to, my god, what am I doing? I'm just spacing the hell out over here. But moving from that to resin 3D printing has been a bit of a challenge. There's just a lot of things that are different. But the results when they come out are like so nice. Oh god, that is so huge. What the hell? Okay. So those are the keycaps I have made myself for the top left for recording and playing back macros. So they are done. Although I do have a different design which is still sitting, waiting clear coding. But basically, yeah, that's about it. I'll also be making an encoder knob in the same material, so it'll match. But that's it for my pre-manufacturing notes, so to say. And I guess we are gonna jump straight into the PCB design. So let me just get rid of this. And these. And let's talk PCB design. Oh, so talking about the software that I'm going to be using for this. I am going to be using KiCad for my PCB design. The layout that I showed you before, that was done in using Keyboard Layout Editor, which is a website. After the stream, I'll try and put links for all of the open sourcey sort of things that I've used. Keyboard Layout Editor is just a fantastic piece of kit for coming up with keyboard layouts, unsurprisingly. But there's people have made a lot of tools that interface with it as well, some of which we'll be looking at later on. In fact, some of which we'll be looking at right now. So yeah, I'll be using Keyboard Layout Editor a bit. I've used some of the software on the QMK website, I think. We'll talk more about QMK when the time comes to flash the board. But apart from that, KeyCAD is going to be what I use for the next couple of... I think it's going to take me a couple of streams to get this done, to be completely honest. I'm not a brilliant electronics person, and it's going to be a slow process. All of my settings were on my old PC, and I moved to this one somewhat recently, so God knows if everything is even set up right on this. I'm also going to be... This is a long introduction, isn't it? So I'm going to be following along with a couple of online guides, just because I can't remember how to do all this stuff on my own. I've followed these guides in the past, and they've resulted in me designing three working keyboards now. So good enough. And the guides I'll be following, again, I'll link these in the description, are AI03's PCB design guide and Master Zen's designing a keyboard from scratch series. And both of those are unbelievably good resources for a first-time keyboard designer. They cover all the basics on KeyCAD. I mean, I couldn't have done it without these guides, so they are pretty spot on. So KeyCAD I'll be using for the PCB, and I'll cover the rest of the software when I get into it, but basically coming from a product design background, I'll be using SolidWorks for designing my case. I'll be using Maverick Render to visualize, just to make it look pretty, just for pre-manufacturing stuff, because I like to render stuff out and see what it's going to look like. And I also will be using Kanban for my machine plotting before I do the manufacture stuff. And that's about it at the minute, I believe. But yeah, so let's jump into it. So, welcome to KeyCAD, which is a PCB software thing. So I've already made myself a project file here, and basically you have to make your schematic, and then you can make your actual PCB layout. So schematic will come first, and this is what we have. We have a blank page. So I'm going to start by just dropping in the MCU, which is the chip, the brains of the whole keyboard. And I am going to be using an 80 mega 32U4. Which is a 32U. I think it's an AU. I'm pretty sure. Since I mean, in the past, I haven't done this like completely from scratch, because what I did was just copied across my whole my whole MCU section. But since I'm doing this on stream, I thought I'd do it completely from scratch, which is obviously going really well so far, because I can't remember where anything is. Alright, oh god, zoom's a bit sensitive. So yeah, basically this is a representation of the microchip, which is in reality it's a square with 11 pins on each side. But yeah, so now we need to start joining all these pins to things. So we will start with adding some power. So first I want to add ground, so oops. Let's put a ground down here, and oops. Oh, damn it. So W is your wires. So that's basically just hooked up the grounds on the PC, the 80 mega to ground, unsurprisingly. And now at the top here, we are going to be joining this to 5 volts. So again, P brings up the power symbol menu, and we want 5 volts. And we are just going to put that. You know what? Let's just put it over here, and just again W to join those, and then that hooks all of that up to there. Right. So what I'm going to do, we need a crystal. So that's what xtal stands for. Copy. So I'm going to do the crystal on a separate little section rather than hooking everything up right here. So that's basically, if you make a label, then you can just reference, it just becomes like a reference you can pull up later, or at a, so if I make this xtal1 label flag thing, then I can always make the circuit somewhere else, and if I put another flag on that circuit with xtal1, then it basically joins those two together. And that's that. Oops, for that. What next? So, just finish my copy here, just a sec. Okay, that's it. Now I should have enough caffeine to get me through some of this. So I'm going to do the same for the reset and the D plus and D minus pins. So the reset is going to a reset switch. Let's just make that RST. And D plus and D minus go to the USB connector. Oops, missed that. Okay. So now what we need to do is wire HWB/PE2. Again, I'm just following along with the Master Zen guide here. His guide is, I say he, their guide is outstanding. So what we need to do is insert a symbol, which is going to be, because we need a resistor here, so we want a, oops, God, I cannot type, ironic. So we're just going to stick a small resistor symbol over here, and, oops, damn it. Again, we'll wire that to that. And then this needs to go to ground, so that's power and ground. And let's just stick that down there. And wire that as well. And now, if we make the value for this is going to be, this is going to be a 10 kilo ohm resistor, so let's just label that as 10k. To highlight, to edit any of these items, all you need to do is mouse over it and press E for edit, and that brings up the properties, so quite nice. So what am I doing there again? I'm trying to remember what the key is for inserting there. know what? So after this, we want to put a capacitor on UCAP, which is gonna go down here somewhere. So let's put this over here. I can always drag all this stuff around later. And oops. And then again, this needs to be hooked up to ground, so just stick that on there. And the value for this capacitor is, I believe, 1 microfarad. Oh god, I've moved all this around. Good job, self. Yeah, X must be the... Sorry, I cannot remember half the keyboard shortcuts in this at the minute. And I've moved stuff around. Yeah, so X must be to rotate. Great job. Basically, I'll just move all this and stick that up there. Actually, that could be a lot further in, couldn't it? Because there's not really anything else over here. And just get rid of that and rewire it. Right, so that's looking better now. More like what I was expecting. AREF is a reference pin which I'm not using, so I can just put a no connection flag on that. I'm sure there's a keyboard shortcut for that somewhere, but I can't remember what it is. Oh, thank you, Master Zen. It is Q. Literally, just as right there in the description, just highlight over it. Or, sorry, just Q is just to bring it up. Alright, so I think that's it for that, and now we are going to build our little crystal section, which I mentioned up there is where our little flags are for the crystal. So let's grab that. So I need a crystal first. Let's stick it over on this side. I can move stuff around later, which I probably will. So we want a... That'll do. Crystal. And what we need now is... so we need 2 capacitors and then to ground it all. So let's ground it first. So let's ground... And then we want a... Oops. We want a couple of capacitors. This is getting a bit messy, but I'm sure I'll be able to work this out afterwards. And now we need to wire all this together, so we want a wire from there. Oops. This isn't symmetrical, is it? It doesn't matter. Oops. And then we want a... Then we want to insert our flags. So this one is oh, hang on, that's not the right sort of label. So basically this is now our little crystal section, and this capacitor, in fact both of them are 22 picofarad, so I can't remember how to move references. Oops, not that. Ah, it's M for move. That would make sense, wouldn't it? I've put one of these in the wrong place, haven't I? Yeah, so this is... Oh, what am I doing? I'm just going to leave all of these components unlabeled, and I'll just let it auto-reference everything for me at the end of it, because I'm not really that fussy about what things are called. So that's our little crystal section complete. So I can just leave that. If I put that up there and then move everything over. Not that I'm going to need this much space on the board. Alright, so let's see, what do we want next? I'm probably going to make some... I'll do the bones of this now, and then I'll probably adjust it to make sure that it is the same as my previous designs after this. So next we want a... So around the MCU, to sort of filter out any weird little fluctuations in power and what have you, you are supposed to have capacitors to decouple all of the VCC pins on the MCU. So to do that, you literally just draw a bunch of capacitors and join them all together, and then it all works out when you start putting it together in the schematic. But we shall do that now. So let's insert, I think it's 5 capacitors that we want. Again, I'll just stick them over here. And then we can just join all these together. Oops. And do the same on the bottom. And we want the power flags again, so 5 volts up here and a ground at the bottom. And now we just need to label all of these. I think all of them are 0.1 microfarad. Oops. Big difference between 0.1 and 0.1 micro. Nope, missed down. Label here. Oh no, that's the right one. Is that? Yeah. That. Oops. So I'm just making this neater. Okay, so that's all of those done. So that's my little decoupling capacitor block. Just tuck that down there. And next we are gonna add an ISP header, which is basically just a way of flashing this if we somehow lose access to the USB so we can get to the bootloader on the MCU. So we are gonna add a header for that. So that is again back into a symbol library, and oops, wow, I cannot type today. So we just want the 6-pin ISP header. I think we can get away with sticking this down here as well. So we want power flags again, so it's ground goes to ground. Who'd have thought that? And 5V goes to a power or VCC. And now what I'm going to do is just use global labels again. I can't remember what the... Ah, there we go. It's Control H. I was thinking Shift H, but Shift H is hierarchical. Okay, so we want MISO, MOSI. I have no idea if these are acronyms or whatever, but I'm just going to say what I say, and it is what it is. MISO. Like the soup. So to rotate, literally it's just R. Okay, and now we need to connect these to the... Where is everything? Okay, I'm not going to pull up the datasheet because it's about 300 pages long. But I'm just going to connect these to what MasterZen says, and then I'll cross-reference against my board afterwards, my design, just to make sure that they are the right ones. So I want SCK on pin PB1. I want that on PB2. And I want PB3 for MISO. And I've already connected, oops. Already connected up my reset flag. my reset switch flag to reset. So that matches with what I have here. So because my keyboard has so many switches, I'm going to talk about this when I get to doing the matrix, but I think I am going to need to double up these programming pins. So these pins for the ISP header are only really used by the header when you're flashing, and apart from that they just sit unused. So you can double them up, which is useful when you have a lot of switches, because an 80 mega 32U4 has 44 pins. But as you can see, a lot of these pins are already getting used for other things. So that doesn't leave that many pins. But we'll talk about that when I start on the matrix itself. So now we're going to do our proper little reset switch circuit, so to speak. So let's drop in a switch here. So we want a switch, and it's a push switch. Okay, so let's stick that there. And we just need to connect. I can't remember how I did this on my other keyboard actually, because it's different from the. Hang on. No, let's just stick with this one and I'll double check after the stream how I had this wired. Because in Master Zen's little thingy, he has made his own little switch schematic, which I'm not sure I can be bothered to make my own. So instead I will just use a generic switch. So again, power flag, we want ground down here. And we want a resistor above it. Oops. And this resistor is going to be... I'll put my flags in first. So I want... reset flag over here, and then just needs all to be wired, so that goes up to there. Well, this needs to be going up to 5 volts actually, so let's just put the 5 volt in here, and then it's a bit long, but whatever, it works. So this, oops, E not R. So this resistor is a 10 kilo ohm resistor, And that is it for the reset switch section. Yep, that's correct. So let's just dump that over there. And now we need to do, oops. Now we need our USB connector. So this one is going to be, in the past, I have always used a mini USB connector in my keyboards because it's a small form factor connector and it works and they're easy to squeeze in wherever you want, and the cables aren't too hard to find at the minute still. But yeah, that's basically what I've used. But now I'm gonna finally bite the bullet and I'm gonna use a USB-C and I'm gonna get with the program and jump into the 21st century. Not that mini USB is that old, but you know what I mean. So I've bought a bunch of HRO USB-C connector thingies. So thankfully, I did actually go out and hunt them specifically because they are the same sort that I used in these guides, and apparently they work. Because I really didn't want to be having to troubleshoot and come up with my own crap for this. So I am going to be using one of these bad boys. And let's stick this over here. So the downside, as you can see, this has a lot of pins, and the old mini USB connectors have like 5. So I'm not looking forward to having to hand solder these, but it's meant to be doable, so I will just have to bite the bullet and do it. So now we are going to need another couple of resistors on the data lines. So that's D2 and D1 are both, I'll put these in line with the D2. Oops. You know what, I'm just trying to work out what would be the neatest way of doing this. So basically the positive and negative, I think, for... Oh no, that's right. So this one needs to go to here. So DP2 and DP1 are connected, I think. Yeah, that's right. So, and then the N1 and the N2 are connected. Cool. And now we are gonna just quickly let's quickly sort this out. So these both need to be 22 ohm. And actually, quickly before I do any more, I am just going to be right back. So my soul will briefly leave my body, but don't worry, I am still here in spirit. Okay, I'm back. Oh. Door. So yeah, let's continue hooking these up. So I've got oops. DP and DN. I think I just made those as D positive and negative, didn't I? So yeah. Okay, and now we want to join up our positives and negatives. So let's join up the shield to the ground and the ground to, well, basically it's just joining all these up, so that is that. And then I think I need to hook that up to a ground at the bottom here. I think. I'm pretty sure I do. I'll stick it in for now, and I'll see later on. And then for... we need to join VBus. Yeah, both the voltage... these both need to be joined up. And I believe... it's just those two, I think. And they both need to go off to do something over here. Oh god. Definitely do not want them joined. So we need a fuse over here. What am I doing? So we want a polyfuse small, which has a value of 500 milliamps, I'm guessing. If it wasn't painfully obvious already that I do not know much about electronics. Don't even know what value a fuse has. It'll be 500 milliamps, I'd imagine. Sounds about right, if a household socket is 13. So this is going off to 5 volts again. And in master sense thing, he is... put a flag in that this is VCC. I guess I could do that. How do you do that though? Yeah, that's a problem for later, I think. Okay, so we are not going to be using this pin, and we are not going to be using SPU1 either, so it can just not connect those to anything. And next is, well, the only ones that are left are CC1 and CC2. So let's see what I need to do with those. Okay, these need to be connected to ground via a resistor. So let's stick in a resistor for each of those. So that, oh, why do I keep typing R for resistor? I am so dumb. For real. Okay, let's bring these over here actually. And so that wants to be a value of 5.1 kiloohms. And let's just move that across to this side. Yeah, now we're talking. And this one also wants to be 5.1k. And then I just need to hook all this up to the ground. And this one goes to CC2 and this one goes to CC1. And then the very last thing we need to add in, you know what, let's move this down to give myself a bit more wiggle room, is we need voltage protection, voltage? ESD protection. So, again, this is stuff that I haven't sort of needed to bother with on oops. Alright, so the last thing we need is a little, it's a little chip, I believe, that goes in and basically yeah, one of these bad boys. And that's not there. That doesn't look like what I want. Ah, that's the one. I might need to move some of these over a bit as well, just to give myself a bit more room. Okay, so where does this need to go? So we want to hook this up to here, and oh, hang on, he's got the, that's it. Okay, so that goes to there, and this, for God's sake. That goes to that. That looks so janky. No, let's move that. Okay, so pin 3 connects to the negative rail, and okay, and then we want to join up, and can we just move this up? Probably make more sense, wouldn't it? And then join this to here. And pin 4, I need power flag for VCC, don't I? Oh, that's also what I wanted over here. Okay, so that's, I think, it. Let me just give that a once over. Well, it looks like what I'm looking at here, so I'll be double checking all this stuff later off stream, so I'm sure that'll be fine. So let's just stick that over there and save, because I haven't actually saved this in God knows how long. And yeah, so we've got all our little bits. We've got our MCU. We've got, yeah, space is that bit better actually. Our MCU here. We've got our reset switch, our ISP header, our capacitor loop, and our crystal section. So next we are gonna do the matrix, which is a joy. So I'll do this on a separate sheet because it takes so much space. Oops. Let's just put this down here. So now I should be able to jump to a new page for the matrix. Oh dear. And now comes the fun part. God, I love wiring up a matrix. So I'll just make one switch to start with. Let me just find the right looking one. Okay, here we go. So basically, a switch matrix, you've got your switch in a keyboard. Obviously, every individual switch has to be wired to the MCU, and keyboards have many switches. So say on, I can't remember how many this has, about 80, somewhere around that figure. Obviously you couldn't wire 80 switches individually, one per pin, to the MCU, otherwise you'd need an MCU with like 100 pins, which would just be wildly impractical. So instead, the switches are wired in a matrix. So all of they're all wired together on the rows and all wired together in columns as well. So if you had 8 by 10, instead of needing 8, like one per switch, you've then got 8 rows plus 8 columns, which is many less pins than 2 per switch. So you would need, there'd be say 10 rows and 8 columns, which is 18 connections. I think that's how it works. I can't remember the math. Don't hold me to that on the math. But so each switch, because it wouldn't work otherwise, you need a diode so that the electricity can only flow through in one direction. So you have a diode on the row, and the columns all are all wired together. So every switch is wired together straight on the columns, and then a diode on the row. So that way the MCU knows if which switch is pressed, and it also gives you N key rollover because it'll know you can press more than one, and because it knows which pins there is electricity coming to, then it knows which switches are activated. So I am gonna insert my diode. Just checking if this is the right one. I'm pretty sure it doesn't really make any difference, I don't believe. Yeah, just diode. Just need a generic diode. It does look pretty big though. There's no smaller diode models. But that is a lot of diode models. Wow, why are these so spicy? Ugh, you know what? Let's just stick with this one. At least it's visible. So this is the basics of what we've got. So we've got switch, column, row. And what we need is one for every single key in this matrix. So I'm gonna have to pull up. Let's just grab a thing on my second monitor so I can actually see what it's supposed to look like. What? Okay, so. And then I'm also going to need to put the encoder in my matrix, which is going to be fun, because there is no guide for that. Okay, so what sort of spacing do we need? Alright, I'm just trying to work out how many switches I need in this, how to build this. So I need 1, 2, 3, 4, 5, 6 rows. Yeah, there's going to be 6 rows and many columns. Oops. Don't like how it, when you select something, it just moves the entire... How many is that? 4. Alright. So now we've got 6 columns. 6 rows, sorry, and 2 columns. And, you know, I guess I could just fill this entire screen with switches and then just delete the ones I don't need. That might be easier. Actually, while I'm at it, I guess I'll talk about the matrix itself. So, the problem I have is that a 44-pin MCU is not a lot of pins when you're designing something with this many keys. So what you end up having to do I'll just bring this up. So this is basically how the matrix looks. Because of the... You can see it's got 16 columns, because column 1 is 0. The first column is column 0. So we've got 16 columns and 6 rows, which is 22 pins needed. But the problem is, I don't think I have 22 pins, especially since I need an extra 1 or 2 for the encoder in the corner. So as a result of that, what I'm gonna have to do is I'm gonna have to what's the term? I'm gonna have to, is it multiplex? I think I'm gonna have to, is it multiplexing? Either way, I'm gonna have to double up columns. I'm sure it's called multiplexing. Either way, so I'm gonna basically have to double up the number of, so, oh, for God's sake. How many is that going to be? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 16. Can I get rid of this in the corner? Because I don't really need my sheet information, do I? Okay, so we've got a 16 by 6 grid. Yeah. And what I effectively need is to join up the... So if I join up the column on each of these... Oh, yeah, that's good. Okay, so I should be able to just wire these straight from there, straight up to there. Yeah, okay. Oh, you know what? Before I do that, I should probably label all these switches so I know what's what and I can get rid of the ones I don't need. So I'm going to bring up my... So on my other screen, I'm just comparing my schematic for the matrix against my image from keyboard layout editor, so I know what row and what column is what. And let's see. So this is going to be that's going to be record. And this is going to be play. And then we've got escape. And then we've got F1. This is going to be a very exciting period of the stream, I can just tell. F2. F3. Oops. F4. I really don't want to miss one because it'll throw all the rest of them out. F5. F6, F7, F8, F9, F10, F11, and F12. And now this one in the corner is not actually a switch. This is going to be a rotary encoder. With a switch. Which is going to be fun. You know what? Let's move that over here. I can probably just put flags on here actually, can't I? I'm sure this is just a case of it just wires straight to there. It's not very neat, but whatever, it'll do. Alright, so we've got the encoder in. And now we are going to move on to the next row, which is fun, isn't it? Okay, so second row we've got macro 1, and because of the way I've wired it, so I just labeled it, this is going to be macro 6. So my macros are going like down vertically, so I've got M1, M2, M3 going down over, and so on. So now we've got, oh, whatever the hell this key is called again. Yeah, whatever. Literally the least used key on my keyboard, because I've literally never needed it. I'll probably replace it with something else, to be honest. I remember once I did keyboard and forgot to put the diodes in on the thing. Oops, N, idiot. Yeah, that was a bit of a pain in the ass having to go back and do all of that afterwards. Anyway, whatever. And what is... Oh, that's backspace, isn't it? Alright, I'm just going to work back along the other... So this is enter. And then coming backwards, we have got square brackets. And then this is some riveting stuff. Should be tab, I think. And that should leave, yeah. So that's going to be macro 7 and macro 2. Now we want macro 3 and, unsurprisingly, macro 8. Couldn't read that for a second there. And now we have caps lock. Not that I use that very often, but it's still useful occasionally. Just looking at how many more I've got to do. It's quite a lot. Should be that. And then what? And that is actually it for that row, because we don't have another switch on the end, so how many more rows have we got left to do? It should be 2, shouldn't it? So I should have done 4 by now. Okay, so we've got... Yeah, that's right, that's right. Okay, so macro 5 is next. And then should be macro 9. And then we've got our wee little... Oh, hang on, I'm editing the wrong one there. Now we should have a little 1.25 U shift. And then we're on to... That key's not allocated right on this computer. I should have backslash, but... God knows why that didn't. It's better when you haven't actually got the key on the keyboard and you have to look it up. So we've got backslash, and now we want our bottom character row. So once I get all of this done, then it'll be a case of should be, yep, that's up. And this is my old favourite, delete. And then we want right, left, and then we've got function key here. And now we get rid of a ton of the keys. So I'm going to start again at the... how many do I skip? Yeah, I skip 1, 2, 3. So I can delete the next 3 keys because we've gotten... there's nothing next to space. So that's these 3 can all go. And this is space. And then I get rid of the next 3 as well. And because there's so little there, that's normally where I end up putting my MCU. Squishing all the components in can be a real pain. So this is Alt, and then we've got I know Win keyless keyboards are a popular choice these days, but I still like having the Windows key. And that should leave us with, yeah, that's worked out okay. So we've got macro 10 and macro 5. And it might not look like it, but this is what my keyboard looks like. It's certainly something. Right, so let's start wiring. So we'll join up the columns. And what I'm going to do is I'm going to duplex, that's what it is. Duplex the columns. So multiplexing was right, just not quite the specific terminology I was looking for. So by duplexing the columns, I'll be able to use fewer pins. Oh, missed that one down there. Oops. Right, oh no, wait, that lines up. Nifty. Okay, so that's that one done, and now we need to join up the rows. Which I'm pretty sure is as simple as just joining up the rows. I think I'll put all my flags at the... Let's double check. So I've got my array done, and so now I just need to add my global labels for each column and row. But this is the point where I'm going to start duplexing, so I need to join... I shouldn't have joined the rows. Alright, I'll get rid of the rows. Right, so what I'm going to do is... I was thinking, what the hell have I done wrong here? So these are going to be paired up like this. So instead of there being 16 columns, there's actually now only going to be 8 columns. And instead of there being 6 rows, there is going to be 12. Right, so I need to... I'm just going to drag all this over so I can actually fit it in. And I guess I'll label my columns now, while I remember. So that's... So it shows us 7, but that's because it starts at 0. So we've got 1, 2, 3, 4, 5, 6, 7, 8 columns. And now I'm going to make all my rows. So... so let's do these one... I'll come down 1 row of pins below there. I'll do that. And we'll do... God damn it. The way the snapping works in this can be a bit of a pain in the ass at times. Swear to God. You know what? Let's just... Gone down 1 too far there, haven't I? Okay, okay, that's better. Alright, so, next one. Nearly there. Nearly there. Just got one left to do. Alright. So now I just need to hook all of these up. So these are the rows. So we've got paired rows for each column. Sorry, for each, since we've duplexed the matrix. This is somewhat tedious, as you can imagine, but needs must, needs must. Missed it. Oh, my eyes are getting a bit tired. But I'll keep going for a bit and see how far I get. It'd be nice if I could get the components laid out at least in the PCB editor, and then leave root tracing for the next stream. Oops. Because tracing's... it's tedious, but kind of fun at the same time. Unlike QMK, which I find tedious and not fun. Ugh. Posture check. Alright. So... that's done. Okay, so now I need to label all my rows as well. And I'm just gonna... Jesus. Didn't think I was that tired, but apparently I am. Okay, so here we have it. So we've got a matrix with all of our switches. And I've got all my references here for all the different rows and columns. I'm not going to bother allocating those onto the MCU yet, because I don't know where they'll need to go to. That's always something that I leave till the end. And Yep, I've got my rotary encoder up at the top here, which I've wired into the switch matrix for the switch, because it's a push button switch on the top of the encoder, and I've got my 3 outputs from the encoder. I don't know if there's anything else that needs to be added to that, but I'll have to look into that. And then basically I think that's it, and now it's time to start adding all the references. So I guess if I now we've annotated all of our switches here. Oh, you know what? Probably would have been better if I'd that's better. So sort of done by yeah, that's cool. So now if you dip back onto our other switch sheet, they should all be these are all numbered now. Alright, just checking against what I have here for what I have. So I guess I need another 5-volt power flag on V bus. And I think, well, I guess for now I could just bung all of the references in, and at least it would be done for importing. So we want to add the columns and rows and the encoder. So let's just start at the top and work our way down. So, oops. I don't know if I'm going to have enough... no, let's leave that for the time being. And let's just start with the columns and rows. So let's do rows first. How many did I say I had? It goes down to 7... So 5 pairs of rows. It's 8 columns. I don't know if I'm gonna have enough, but we'll find out. Ooh, I am definitely not gonna have enough. Just by 1 pin. Because I didn't use the... So I've got rows 1, 2, 3. Shit, I forgot row 2B. Okay, so I need row 2B down here as well. I'll have to move a lot of these around, I think. But it doesn't make a lot of difference. You know what, let's just do that now, actually. Alright, so rows 1, 2, 3, 4, 5, 6, and columns 1, 2, 3, 4, 5, 6, 7, and 8. Oh wait, I don't need a column 8. That doesn't exist. So I still only need 1 extra pin. Which I guess I could just double up on these 3. So these pins aren't used. So miso is enc A. That's right, isn't it? Miso is enc A, Mosi enc B, and SCK is enc C. Right, and alright. And that is it. So now I need to assign footprints, I think. I wonder if I should run the ERC. SW1. What is that? That's this one, isn't it? Hmm. Yeah, I've got those two markers which aren't connected to things, which is fine. What else? Oh, that's not connected. Hang on. There's that one. Interesting. Where's the next one? The hell? Oh, I need to add power flags apparently. Ugh. Alright, let's try that again. Hey! Okay, so that's the only things that it's listing are pins 37 and 36 not connected, which I knew about, because there's nothing connected to them at the minute, but there may be later, so I'm not going to flag them. Cool. Oh, right, so footprint time. Right. This is going to be a fun task. So I think I've got 0805 component sizes for basically everything. All my diodes, I'm sure, as are the capacitors. And the resistors, I believe, are all 0805. I think even the fuses, come to think. Why am I not seeing anything in the library? My library has disappeared. Lovely, just what I wanted to see. This is the sort of thing I thought would probably end up happening. Just... the hell? My library's all here. So it's a legacy? Does that make it better? Nope. Oh, I've got no idea what the hell's going on here. Lovely. Okay, I might have to leave this for now and do some troubleshooting. But either way, we have got a schematic, which is done. But I might have to do some troubleshooting to find out what the hell is happening to my library. Of course. And come back to this one later. So I might be back. I don't know. That's really annoying. Because I can see my library in here. But that is infuriating as to why my library's just disappeared. Oh, hang on, is it? Is that it? Nope. Okay, well, I think I'm gonna have to call it here and then come back once I've worked out what the hell is happening to my library. Otherwise, it's just gonna be me getting frustrated. But, yep, we have a schematic and we have a matrix, so it's a good start. But we'll come back to this once I've worked out what the hell has gone wrong. So for now, I'm going to call it, and thanks very much, and I shall see you again later.